We continue on with our study of trigonometry and right triangles with the next video. You can see the objectives that are listed right here, so let's get to it. I'd like to do just a quick reminder of the 6 trig functions. Most all of you know this, but I want to relate it to this unit circle where the radius of the circle is 1. This is the angle theta, which is drawn in the first quadrant but could be drawn anywhere else. You could draw a triangle anywhere else. This is the x value, right? This is the y value for this point that's on the circle. All right, so the 6 trig functions written using, you remember so, ka, to, a, right? Sine, opposite over hypotenuse, blah, blah, blah. Okay, so let's fill in these. So we have the sine is going to be y over 1. The cosine is going to be x over 1. And the tangent is going to be y over x, right? So technically, if I'd left off the 1 here in a unit circle, y would be equal to sine theta, x would be equal to cosine theta. Okay, and so if you think about it, y over x would be equal to tangent, so that would be equal to sine theta. I don't know why I didn't write that. Sine theta over cosine theta. All right, and then the reciprocal functions. Okay, which means that the cosecant is a reciprocal function of sine. It's the c and the s are opposite. So that would mean that this is 1 over y, that the ratio would be the reciprocal and the function could be reciprocated. Then 1 over cosine, which is 1 over x, and 1 over tangent, which is x over y, which is also cosine over sine. These are important. Please write them down. So finding the ratios and angles of sine, cosine, tangent on a calculator is as easy as you think it is. It is pressing the sine button, putting in 40 degrees, and writing the ratio that it returns. Okay? Because the sine of an angle is equal to a ratio. The cosine of an angle is equal to a ratio. Now, the sine 40 degrees is in the first quadrant where sine is positive. This ratio is positive. But the cosine of 131, remember 131 is in the second quadrant where cosine is negative. So this ratio will be negative. Now, finding if I've been given the ratio for a function, then I'm going to add this piece to it, and I'm going to use the function that's right above the sine, cosine, and tangent keys. So in other words, the inverse sine of a ratio will equal an angle. So I'm going to be using this method on the calculator to find the ratio given an angle. This time I've been given a ratio and I want an angle. So if I put 0.9962 in here, I should get 85 degrees. Note that there are no keys on a calculator for the cosecant, secant, or cotangent functions. To find them, we have to use the fact that sine and cosecant are reciprocals of each other. Okay? There are different ways to find, for example, the cosecant of 37 degrees. And you see I have it written here. One way is to note that the cosecant of cosecant is the same thing as the reciprocal 1 divided by sine of 37. And when you do that, you're going to get the ratio 1.6616. That's probably the most straightforward way to do that. So another one would be if you wanted to find the cotangent of 23 degrees, right? You would do 1 divided by the tangent of 23 degrees to get that answer. And that's pretty straightforward. The other comes when you are given you want to find the inverse tangent, or the inverse. They give you the ratio and they want to know what the angle is. So instantly, probably to you, here is a problem. So I want to find the inverse secant of the ratio 5.8621, right? So this is a ratio, and what I want is the angle that right triangle makes with that ratio. Okay? So what we did above is we would just do 1 over cosine. And that's not exactly right because we're talking about a ratio here. But I do know that the reciprocal function of secant is cosine. So what if I wanted to use the inverse cosine of a ratio to find an angle? Okay? So if I just put in the inverse cosine of 5.8621, I'm going to get an error, because 5.8621 ratio cannot be in a cosine for a cosine angle, because remember it is adjacent over hypotenuse and it will never be bigger than 1, right? Because this side is always smaller than the hypotenuse. So that won't work and it'll get me an error. But I do know they're reciprocal functions, which means that I could do, like I did up here, I could do the ratio as a reciprocal. So what if I did inverse cosine of 5.8621? And that would get me an angle. And when I do the calculations, that's going to give me 80.178 degrees. And remember degrees, minutes, seconds. All I would do is I would say 80 degrees plus 0.178 times 60 minutes plus whatever decimal I had left over times 60 seconds. So if I needed to convert that back, I could. So remember, you're using the reciprocal, but you're always going to be using the ratio. You're going to be using the ratio as a reciprocal. Your calculator can take trig functions and inverse trig functions to extreme accuracy. However, if you input the problem into the calculator incorrectly, one of two things will happen. You will get an error. You've used correct syntax, putting it in, but it's telling you that it cannot accomplish the problem. The other thing is, you can get an answer, but it isn't going to be correct. So there are several things that could go wrong. One, your calculator could be in the wrong mode. You could be inputting angles that are in degrees, but your calculator's in radian mode, or vice versa. Domain errors. For example, if you take the inverse cosine of 1.345, you're going to get an error. Because in a triangle, the ratio for cosine is adjacent, a leg, divided by the hypotenuse, which is always the longest side. That means your ratio can never be bigger than 1. It can't even be equal to 1 or it's not a triangle. So that could give you an error. You also can have an error when you believe your calculator without determining whether your answer makes sense. And here's an example that I've given you here. This is the right way to calculate the inverse cotangent of the ratio 3.5. And you can see you take the reciprocal of the ratio and then the arctangent, the reciprocal function, and get an answer. And this makes sense that this would be an angle. You could do it this way. You could find the arctan of 3.5. It's going to let you do that instead of taking the reciprocal ratio. Then take it and then do this, you get this tiny little number, and it doesn't make sense. One way to correct some of these mistakes is to work the process backwards. Remember, the cosine of an angle gets you a ratio, and the inverse cosine of a ratio will get you the angle, and that's demonstrated here. I took the sine of 85 and got a ratio. Then I took the inverse sine of the ratio and got my angle back, right? And you could also do it this way. So here's two different ways that you could check your answer. And asking if an answer makes sense and checking it against what you know is an important skill in mathematics. Solving a right triangle means finding all the missing parts. So generally you'll be given a triangle. You can see how it's marked on this page. And then you're given certain pieces of that information. You're told the hypotenuse, one acute angle, and of course the right angle is always 90. And then you're going to use your trig techniques to solve or find the rest of the triangle. And so you can see here you have a diagram. This is your diagram marked. And then you have this spot right here. If you were writing this on your paper, you would list all the angles and all the sides and underline the parts that you need to find, just like it's done here. Now, the easiest thing probably, you could start anywhere to find this. But probably the easiest thing is to find angle B. Because, and we've done this before, how do we know this? Well, we know that in a triangle, it's equal to 180 degrees, and one of the angles is a 90. So that means that I have 90 degrees left. I subtract the one given acute angle, and I get 69 degrees. So this is 21, and this is 69. And I know because all three of those add up to 180. All right, then I want to find a missing side. And A is first, so let's pick A. Well, A is opposite the 21 degree angle. So opposite, and I know the hypotenuse, would be a sine. So the sine of an angle, 21 degrees, is equal to the ratio of the A side over the hypotenuse. They're equal to each other, so I can use them to solve. Then I could multiply both sides by 14, and I get A is equal to 14 sine of 21 degrees. The answer is going to be 5.017. It's not 5, right? It's not 5. It's a little bit more than 5, okay? And that is degrees. Or that's not degrees. What am I doing? That's just the side. All right. Then to find B, you could use any, right? You could use several different methods. You could use the Pythagorean theorem. You have two sides. So c squared equals a squared plus b squared. You could say that the cosine of 21 degrees is b over 14. Or you could say that the sine of 69 degrees is b over 14. Right? Now think about why you could do that. Why is the cosine of one angle equal to the sine of its complementary angle? And think about how ratios are set up in a right triangle. Both of these will get the correct answer. In fact, any of these three methods will get the correct answer, which is 13.0701. All right, and now I have solved this triangle. If you're given degrees, minutes, seconds for one of your angles, you may have to convert that to a decimal so that you can use a trig function to find the sides. Don't round too much. All right? And so on this assignment, you work together. You'll be able to think about different ways of doing these problems, but try to deepen your understanding of right triangles in this lesson. See you in class.